10.3 is displaying data part 2. And so really it's just a continuation of what we did last time in 10.2, which is just more different kinds of graphs and displaying of data. So the first one we're going to look at is one that's actually very familiar to you. You may not have thought about it this one before, but it's called a line graph. A line graph has line segments connecting one data point to the next, typically showing the trend of a variable over time. Think connect the dots. So you see line graphs in the stock market, right, when it goes up and down. You see line graphs, you saw line graphs during COVID. I mean, they put all kinds of line graphs everywhere. They had lots of kinds of graphs, actually, but that was one that you saw a lot, whether it was total cases or cases, new cases or something like that. You see line graphs when you look at, they look a little bit more curved. When you look at growth charts for children, those are line graphs as well. They just try to connect the dots a little more smoothly, not with the segments necessarily. But this is what happens when you're trying to say that something's happened again, typically over time, something's changed, okay? So you'll notice all the descriptions I gave are things that changed over time. The stock market, the deaths for COVID or the cases for COVID, the growth charts for children, all of it's over time. That isn't to say that you couldn't make a line graph with other data, it just doesn't make as much practical sense, okay? So the one we're gonna look at is actually study hours in a given week. So this isn't over time in terms of the long haul, but time in terms of a given week. So a learning specialist tracked the average reported study times for her students, and we're gonna create a line graph for the data she tracked. So a line graph looks like an XY coordinate axis where you just have quadrant 1. So you're just going to have, just like when we did bar graphs and histograms, you're just going to have that first quadrant of data. The bar at the bottom, the horizontal bar, is going to be the time, all right? So in our case, those are days of the week. And so I'll label them with just the letter day of the week. So we've got Monday. They still need to be measured approximately evenly apart, right? So whatever distance you do between Monday and Tuesday, I'll do to you for Tuesday. You want to do that same distance when you get to Wednesday, and then Thursday, and so on. Friday, Saturday, and Sunday. Now, as with every other graph of this nature, we have to label our axes. So this one at the bottom is the day of the week. And what is our vertical axis going to be on this? It's not frequency. That's what it's been on all the others. What is it on this one? Yeah, it's hours, right? It's whatever we're measuring. So if we were talking stock market, this axis would have been, right, the value of a stock. When we were looking at, COVID cases, it was cases or deaths. If you're looking at growth charts, you're looking at centimeters or pounds or something like that, however you're measuring that child's whatever you're measuring. So this actually will end up being an actual quantity of something, not just counting something typically. So over here, it's a number of hours. So we are counting something, but counting something specific with units. So my data on this graph, if you look at the data, is all measured in quarter hours, right? So I'm going to measure my hash marks in quarter hours, and just like before, I tend to label every other one so as not to make my graph kind of a mess. So I've got the half an hour, the 1 hour, 1.5 hours. Looks like I need to go up to maybe about 2. So here's 2 hours. Does that look okay? Again, this is a place where if you have graph paper and wanted to use it, it might be helpful, or print some off online. So on Monday, we're just going to record a dot for every data value. So the first one says on Monday, the child or the person studies 1.5 hours. So there's this right here. Okay. On Tuesday, they study an hour and 75, or not 75 minutes, but 1.75 hours. So we're right up here. On Wednesday, it's 0.75 hours. So we're down here. What happened on Wednesday that made that happen? I like to think it's church. We're going to go with that. Church happened, right? Church happened. Thursday, 2 hours. So any guesses as to why somebody might be studying so much on a Thursday? Seems like tests happen a lot of times, at least in high school and below, on Fridays, so the end of the week kind of thing. So that's what I'm guessing is probably the case. And then I'm pretty sure that the people on Friday and Saturday lied and said that they studied for 0.25 hours. That sounds like a lie to me. Oh, wait, I got one off. There we go. I don't think they're studying on Friday and Saturday. Although I did have one child who would always do her homework right on Friday when she got home from school, so she didn't have it the rest of the weekend. Super smart, but that wasn't me either. All right, the last one is Sunday for an hour and a half. All right, so Sunday was 1.5. That's where we were when I paused. So we're right here. 1.5? Yeah, 1.5. Looks like that. Okay, so my dots aren't super clean, but I think they get you the gist of what's going on, right? And we're going to connect across the graph from left to right, dot to dot, just like you would with the Chili's menu with the connect the dots puzzles, right? So it looks like this. Like that. There's one more thing this graph needs. A title, that's right. What might you use for a title for this graph? Sounds good. We'll go with that. Average study time throughout, and we'll say a week because we don't know how general this is, right? Throughout a week. Okay, so this might be something where if you were doing this from week to week to week, you looked at a pattern to see what weeks look like. Does every week look like this? Is this just a specific week? Those kinds of things. A lot of times these graphs look at data over a long period of time, right? Like the life of the stock, right? How long the stock has been in existence or something like that. So it might be a really long period of time, 40 years or something, right? Or in the case of head circumference for a child, they track that for about 2 years. And so that would be over the life of a 2 years worth of every child that comes into this pediatrician's office or something like that. So it's generally over a time frame, and they're trying to gauge whether or not something makes sense for whatever the context is over that time frame. Okay, the second one we're going to do today is called a scatter plot. Scatter plots are often used when relationships between variables cannot be easily depicted, even by a broken line. Now, the scatter plot that I'm going to work with you on is far more involved, like way more involved than anything you're going to see in your notes or in your homework. The reason it is because I'm trying to achieve two things at once. One, how do I create one of these things? That's fine. And so this one's going to be like overkill for that part. But then if you're given a set of dots, which you will be, a scatter plot, how do I create a line of best fit through it? So I'm trying to do both things in the same problem. So that's why this feels like it's going to be like over the top, okay? All right, so here's my data set. It's a big data set. This is Coach Lewis, and he kept track of the vertical jump heights in centimeters of his starters over 8 years, okay? Goes from the year 2002 to the year 2008, and he's got his 5 starters. It's got to be basketball, right? That makes sense, okay? So I even have, oh my goodness, I don't. I thought I had it set up here. Maybe I've got it at the end. There we go. A grid. We're going to do a grid for this because it's really difficult to do without, at least for me on the screen, because I have to zoom in and zoom out so much, without it. So just do the best you can on your paper, keeping track of where everything are on the paper. But what we're going to do is a couple of things that I need to make you aware of. The first is we're going to have a big, long graph, and it's going to look like that same XY that we had done on several of them now. We're trying to gauge vertical jump height, which means the jump height is going to be over here. And we haven't had this situation come up quite just yet, but now we do. We need to say how it's being measured. So this is in centimeters. And so you can just put centimeters there next to it. The units matter. Okay? Now, generally speaking on a graph, the x-axis down here is 0, right? It's 0 jump height. Well, these numbers don't make sense to talk about having a 0 jump height on my graph. So take a look back at our jump heights and tell me, where does it sort of maybe make sense to start? What's my smallest kind of value in this data set? 58? Okay, so what I'm going to do is I'm going to break this graph right here, and I'm going to put in this jagged edge that tells you that this does not go down to 0. I've got a break in my graph. So I literally write a break in the graph, and I start wherever I want to start. In this case, we decided it looks like I need to start at 58. We're going to hope that I've got enough space to the top for my values. How high does it need to go? What's my biggest value? 77. So I'm going to make hash marks all the way up to 77 and label every other one. We're going to see how close I am to getting this able to work. Man, okay. It's all right. I can move my graph down a little bit. All right, barely on my screen, okay? And we're going to be measuring it with the years that were given on the horizontal axis in the bottom. So we're starting at the year 2002. So I'm actually going to write, you know what, for something else we're going to do later, this isn't going to make sense today because we're not talking about this part of it today, but we're going to let this axis right here be the year 0, like the year 2000. And so then we're going to start 2 units away for this to be 2002. And then, okay, I can't label it that way because I'm not going to have space. This is 2002. I'll just use this unit digit. And I have 2003, 4, 5, 6, and 7. So it's going to be really compact in here. If you wanted to spread those out, that would be okay. Just make sure that you've got the same distance as you have right here for 2 years worth. Since that's what I'm labeling, I want my axes, my vertical axes to be the year 2000. And it will make sense why when we get to Monday, okay? All right, down here, these are going to be labeled. This axis, rather, is going to be labeled. Oh, is it 8? Yeah. Thank you. I'll mark an 8 on there too. Did not catch that. I think I was still thinking about the 77 for the height. Okay. Over here, because I've labeled this 2, 3, 4, 5, 6, 7, 8, right, and not 2002, 2003, which part of that was because I didn't want to write it all out. It was too big. Part of it is also on purpose. I really don't want it. I really just want it to be the number of years after 2000. And again, I realize that the reasoning for that I'm not telling you about right now because it won't make sense today. Okay? So we're just going to write it number of years since 2000. Axis is 2000, everything else is years after that. Okay, everybody good? Now we're going to plot a bunch of dots. Okay, so for the year 2002, I need a dot at the 5 heights that are listed here. So 65, 63, 60, 62, and 58. So we're going to put a dot, and they're going to be stacked right up on top of each other, for a dot for every one of the values. So I have a dot at 58. I had one at 60, 62, 63, and 65. In 2003, I have a bunch of dots. This time 62 is my smallest, of 62, 64, 65, 66, and 67. 2004, I have 64, 65, 66, 67, and 68. 2005, I have 65, 66, 67, I have 68, and I have 70. In 06, I have 66 as my smallest one. 67, 68, 69, and 70. In 07, I have 69. That's my smallest one. Gracious, 69. Everybody's got jumping high at that point. 70, 72, 73, and 74. And my last year is 70, 71, 72, 73, 75, and 77. So that's not what you're going to create when you create a scatter plot. Your scatter plot will look a lot more like the first graph that we did today over here without the connections. That would be a scatter plot as well. So a scatter plot is really just the points plotted on the graph. That's what a scatter plot is, okay, without these connections. Okay, so over here, we still need one more thing. What do we need? We need a title. What in the world is all these dots going to do for us?
They're telling us the vertical jump heights of Coach Lewis's starters.
Vertical jump heights of Coach Lewis's starters. Now, what we're going to do next time is we're going to actually try and put a line through the middle of this in a way that it sort of balances the data. But if you look at this right now, I bet you can answer a couple real easy, quick observational things for me. Is this graph increasing or decreasing?
Increasing.
It's increasing, right? As we move from left to right, we seem to be tending upwards, right? So that's important as we make our line because we can balance dots along lots of different lines, but the lines we want to balance them along need to go in the direction that our data is moving, okay? So this is tending upward. It has a what we call a positive correlation, right? It's positively moving left to right, up. We're moving upwards. All right, so we're going to stop right there today. I know we're done early. It's exciting. And we will finish up with looking at this graph next time and talking about the trend line and how we create it, okay?